Hello children. Previously you have studied about complementary angles, supplementary angles, adjacent angles, linear pair and vertically opposing angles. In this presentation we will discuss about the angles formed by a transversal to two or more parallel or non-parallel lines. So let us start. A transversal is simply a line which intersects two or more lines at distinct points. For example, in figure 1, lines M and N are parallel lines and a line L intersects both the lines at distinct points. So the line L is a transversal here to these given lines. In figure 2, lines A and B are non-parallel lines and a line L intersects these lines at distinct points. So again L is a transversal in this case. Similarly, in figure 3, lines M, N and P are parallel lines and a line L intersects these lines at distinct points. So once again L is a transversal in this case as well. But in figure 4 we see that L, M, N and O are intersecting each other at a single point. So since L is not intersecting these lines at distinct points, so L is not a transversal in this case. In both figures, L is a transversal to the lines M and N. In first figure, total 8 angles are formed by the parallel lines and a transversal. Also in second figure, the same 8 angles are formed by the non-parallel lines and the transversal. In both figures, angle 3, angle 4, angle 5 and angle 6 are called interior angles since these angles lie in between two lines or in the interior of the two lines. Similarly, angle 1, angle 2, angle 7 and angle 8 are called exterior angles since these angles lie in the outside of the two lines or in the exterior of these two lines, so they are called exterior angles. Co-interior and co-exterior angles, they are also known as interior angles on the same side of the transversal, or you can call them allied interior angles or allied exterior angles. You can see in both the figures there are some angles on the left hand side of the transversal and some angles are on the right hand side of the transversal. But on the left hand side you can see angle 4 and angle 5 are in the interior of these two lines, so we call them co-interior angles. And angle 1 and angle 8, they are in the exterior of these two lines and they are also on the same side of the transversal, so we call them co-exterior angles. Similarly, you can find the other pairs of co-interior and co-exterior angles. Alternate angles, these are angles which are on either side of the transversal, or you can say which are in the opposite side of a transversal. For example, in the following figures you can see some angles are on the left hand side of the transversal and some angles are on the right hand side of the transversal, so they are alternative to each other. But the angles which are interior angles and in the alternate side of these transversal, for example you see angle 4 and angle 6, they are the interior angles and all at the same time they are on either side of the transversal, so they are called alternate interior angles. Similarly, you can see angle 1 and angle 7, since they are the exterior angles and they are on the either side of the transversal, so they are called alternate exterior angles. Similarly, you can find the other pairs of alternate interior and alternate exterior angles. On the right hand side of this slide you can see there are also some other diagrams which can give you a better understanding of the topic. Corresponding angles, they are simply the angles which are on the same side of the transversal, in which one angle is interior and the other is an exterior angle. They are not adjacent angles also. So you can see from the figure, angle 1 and angle 5, they form a pair of corresponding angles. You can see angle 1 and angle 5, they are on the same side of the transversal, but angle 1 is in the exterior and the angle 5 is the interior. so they form a pair of corresponding angles. Similarly, you can find the other pairs of corresponding angles as well. So far you have understood what are alternate angles and what are corresponding angles. Now what happens when the lines are parallel? You see that when the lines are parallel, then the pair of alternate interior angles and the pair of alternate exterior angles, they are equal. You can see in the first figure, angle 4 and angle 6, they form a pair of alternate interior angles. Since the lines are parallel, so these angles will be equal. Similarly, in exterior pair also, angle 1 and angle 7, they form a pair of alternate exterior angles and they will be equal as well. Similarly, for corresponding angles, when the lines are parallel, then the pair of corresponding angles are always equal. You can see angle 1 and angle 5, they form a pair of corresponding angles, so they are equal. Similarly, the other pair of corresponding angles are also equal. We have already discussed the properties of these angles. I have given you the answers for each part, so you should be able to understand the answers of these parts on your own. Consider this as a part of your homework. But it should be noted that each part can have multiple answers. For example, in part A, we have to write corresponding angles. You should know that in the following figure, it can have 4 different pairs of corresponding angles. But we have to mention only one pair as it has been asked in the question. So that's why each part can have multiple answers. Exercise 9.2, question number 2. In this question, we have to find the angles which are not given in the figure and which are represented by the following variables x, y, and z. Obviously, we have to take help from the angle which is given, that is 40 degree. So we'll start it from here. You can see on line M, angle 40 degree and x, they form a pair of linear pair. And we know the sum of the angles of a linear pair is always 180 degree. So we have started our equation from this 40 plus x is equal to 180 degree. So after transposing the 40 degree on the right hand side, we get the value of x, which is 140 degree. We already know that when two lines are parallel, then the pair of corresponding angles is always equal. As you can see, angle x and angle y, they form a pair of corresponding angles, since they are on the same side of the transversal and in which x is in the exterior and y is in the interior. So they should be equal. But we have already found the value of x, which is 140, so therefore y will also be 140 degree. Now, in order to find the value of z, you can see angle z and angle y, they also form a pair of linear pair. So their sum should be also 180 degree. So you can see z plus y is equal to 180 degree. Since we have already found the value of y, which is 140 degree, so we will substitute that value in place of y. So after transposing that 140 on the right hand side, we will get the value of z, which is 40 degree. Question number 3, part C. You can see in the given figure, we have to find the angles which are being represented by the variables x, y, and z. So we'll start with z. You can see from the figure, z and 110, they form a pair of vertically opposite angles. So z will be equal to 110, as we know that vertically opposite angles are always equal. We know that if the lines are parallel, then a pair of alternate exterior angles are equal. As you can see in the given figure, line L is parallel to line P and there is a transversal M over there. So we see that y and 110 degree, they form a pair of alternate exterior angles. So they should be equal. So we can write angle y is equal to 110. But you can also approach another method over here. You can see y and z, they form a pair of corresponding angles. Since we have already proved that z is equal to 110, so that way also we can say y is equal to angle z and z is equal to 110. So that way also you can get the value of y, which is 110. So you can approach any method over here. Now how to find the value of x? We see that on the line P, x and y, they form a linear pair. So we know that the sum of angles of a linear pair is always 180 degree. So we have written the equation over here, x plus y equal to 180 degree. Since we have already found the value of y, which is 110 degrees, so we will be substituting that value of 110 in this equation. So we'll write x plus 110 equal to 180 degree. So after transposing 110 degree to the right hand side and simplifying, we get the value of z, that is 70 degree. Dear students, you have a homework of question number 3, A part and B part, since C part has been done by me. If you have any doubt or any question, you can contact me. The contact details are provided in the coming slide.